I know this is an unpopular opinion, but I really like the N64 controller. Today we're going to make a full set of custom buttons for the N64 controller, experimenting with some pearlescent pigments and even making a galaxy swirl effect. By the end of this, these buttons are going to look way cooler than anything Nintendo ever thought of back in the 90s. Sorry Nintendo, I am Paul and this is my little mod shop. Now, if you've never done a resin casting before, don't worry. I'm going to take you through the whole process step by step. You don't need to be a pro to pull this off. Just some patience, a few materials and maybe a pressure pot that doesn't look like it came out of a mad scientist's garage. Mine kind of does, but it works. The Nintendo 64 is one of those consoles that a lot of us grew up with. It's got that funky 3-prong controller that still makes no ergonomic sense, but man, it's iconic. And second, the buttons themselves are the perfect size and shape for resin casting. They're chunky, and because the controller has so many different buttons, the A, B, the 4 yellow C buttons, Start, L and R and even the C trigger, we get to make a whole set. That means more room to play with colors, swirls and effects. Plus, once we're done, I'm going to drop them back into the transparent green controller shell so we get to see them in action. Before we can cast anything though, we need to make molds. Resin needs something to cure in, and for that we're going to use silicone. Specifically, I'll be using Smooth-On's Moldstar 30, which is a 2-part silicone that cures into a flexible mold that can capture a lot of detail. To keep things neat, I designed a mold box and 3D printed it. We'll glue it down to a craft board, seal it up and then start setting the original buttons in place with some oil-based clay. Once the buttons are set up, we'll pour the first half of the mold, let it cure, spray on some release agent and then pour the second half. By the end of it, we'll have a reusable mold that's ready for resin. So that is the plan for now. Let's start with the first step, building the mold box. These are the original N64 controller buttons, and before they go into the mold, they need to be nice and clean. You don't want dust or grime transferring into your silicone, because whatever's on the button will get faithfully copied into the mold. Now here's where things get interesting. Not all buttons are created equal. The A and B buttons are nice and flat, and so is the start button, but especially the D-pad and the triggers are shaped in a way that makes them awkward to just plop down. If you were to stick the D-pad directly into the mold box, it wouldn't sit right and your mold would end up with weird undercuts. That's where this oil-based clay comes in. I use a non-drying oil-based clay to backfill and support the buttons. Basically, I build platforms for each button so they sit level in the box. For the D-pad, I press it gently into the clay until it's nice and stable, make sure the top surface is flush. For the other buttons, sometimes it's just a matter of giving them a little clay bed so they don't wobble. Take your time with this step, because however the buttons sit now is exactly how they will appear in the mold. For the rest of the regular buttons like A and B, it is important to put clay in all the nooks and crevices. This not only helps with our plan to make some galaxy swirls later on, but also helps a lot to get the buttons out of the mold. Also, I'd like to mention that I use some IPA to clean up the rest of the clay where it does not belong. Again, just take your time with it, as everything will be imprinted in the silicone. Once the buttons are in place, I also like to think ahead about where the silicone will flow. Silicone is thick and air likes to get trapped in little corners, so I press around the edges of the buttons with a sculpting tool or even just a toothpick to smooth transitions and avoid little pockets. It's a small detail, but it saves headaches later on when you're demolding resin. Let's build the mold box now. You don't need to overthink this part, but you do need something sturdy that will keep your silicone from leaking out all over the table. I went ahead and designed a box that I 3D printed, which saves me a lot of hassle. You will find the files in the description down below, so you can also print out this one for yourself. If you don't have a 3D printer, you could also build something out of Lego bricks, foam board or even some scrap wood. The key thing with your mold box is that it needs to be sealed. And trust me, cleaning half-cured silicone off your workbench is not how you want to spend an afternoon. So what I like to do is to hot glue the edges of my box right down onto a piece of craft board. The hot glue not only seals the edges, but also anchors the box so it doesn't move when we pour the silicone. Give it a good bead of glue all the way around and press it down. I even go back over the seams with another pass of glue, just to be safe. With everything positioned now, it's time to mix our silicone. Like I mentioned earlier, I'm using Smooth-On Moldstar 30. It's a platinum cure silicone, which basically means it's strong, flexible and will last through a lot of casts. The mixing ratio is 1:1 by weight, so I grab my little digital scale here and measure out equal parts of part A and part B. Accuracy is important here. Too much of one side and your mold might cure soft or tacky. After measuring, I combine the two parts in a mixing cup and start stirring. You want to mix thoroughly, but not like you're whipping eggs, because whipping just means more bubbles. Scrape the sides, scrape the bottom, and mix until the color looks uniform. At this point, the silicone is full of air, so before we pour, we go into degas it. I've got a vacuum chamber for this exact purpose. I put the cup inside, turn on the pump, and watch the silicone rise up like bread dough as the bubbles expand. Don't panic, this is normal. A neat little trick that I have learned is to open up the air valve just a few seconds before the silicone rises to the top. This prevents overspill. It is definitely good practice to have a large enough basket or cup for the silicone, as it expands up to 2 times its volume. But once the bubbles pop and the silicone settles back down, you know it's ready. This step makes a huge difference because bubbles trapped against the buttons would leave defects in the mold. Now comes the fun part, pouring. Instead of dumping the silicone right on top, I like to pour in a thin stream from a little height, aiming at the corner of the mold box. The silicone will flow in and around the buttons, pushing air out as it goes. Slow and steady is the name of the game here. Keep pouring until everything is fully covered and then give the box a few gentle taps on the table to encourage any stubborn bubbles to rise. And that's it for the first pour. Now we have to wait. Moldstar 30 takes a few hours to cure, so it's usually the part where I walk away, grab a snack or coffee.
Good boy.
Alright, the first half of a mold has healed and it's looking good. The buttons are embedded halfway in the silicone, the surface is nice and firm, and now it's time to build the second half. This is where things can either go really smooth or you end up with 2 halves of silicone permanently fused together into one sad blue cheese block. We definitely don't want that, so the release agent is our best friend here. Before spraying though, I carefully remove any clay that's sitting around the buttons, making sure not to move the buttons themselves. The goal is to expose the rest of the button so the second half of silicone can capture the detail. The clay right in the buttons can stay of course, as we want the finished buttons to actually have more volume and not be hollowed out. Now comes another crucial part of making the mold. We need to make the vent sprues for the epoxy resin to flow into. I have a lot of toothpicks and chopped up cotton swabs for this exact purpose, as they are thin enough to make contact with the parts, but at the same time thick enough that the epoxy can easily flow. The important thing here is to give every button or trigger at least 2 vent sprues. This helps the air not to get trapped in the mold, and at the same time it functions as an indicator if the button is filled up fully. I gave the triggers 3 vents. As they are so thin and fragile, I really want the pouring to be a success, and this is a good insurance in a way. Finally, with that done, I grab my can of Ease Release 200. This is my release agent of choice. About 2 light and even coats are all you need. I also have a cotton swab ready to be drenched in the release agent, as I apply some more in the crevice of the registration mark. This is super important, as the release agent simply can't get in there covering all the sides fully. And with that also finished, this will make sure the 2 halves of the mold separate later on. Now we mix up another batch of Moldstar 30 the same way as before. Equal parts A and B, measure by weight on the scale, mix slowly, then straight into the vacuum chamber to degas. Watching silicone bubble up never gets old. It's like a little science experiment every time. Now we pour the second half. Again, thin stream from a corner, let the silicone flow around everything. You want it to completely cover the exposed buttons and meet the first half cleanly. Give the mold box a few gentle taps to coax out any lingering air bubbles. Then we leave it alone. Once the second half is finally cured, it's time to demold. This part feels a bit like opening a mystery box, except you already know what's inside. I carefully pry apart the 2 halves, and if everything went according to plan, the release agent will let them separate cleanly. Out come the original N64 buttons, and what we're left with is a perfect negative impression of the entire button set. Another step that I take is to cut the vent holes a little open with my X-Acto knife. This way every button has little epoxy reservoirs. This will be important later when the mold comes into the pressure pot. And there it is. At this point we've got a reusable 2-part mold that can handle resin pours over and over again. The surface is flexible but tough, and the cavities are ready to be filled. And honestly, this is one of the most satisfying parts of the whole project. Holding the finished mold and knowing you can now duplicate as many buttons as you want. So with the mold finally done, it's time to move on to the star of the show, resin casting. For this project I'm using Smooth-On Clear Cast 202. It's a 2-part urethane resin that cures nice and clear, which makes it perfect for adding pigments, dyes and swirls. I know at this point it feels like that I'm sponsored by Smooth-On, but believe me, I paid for all their products with my own money and have no affiliation with them. However, this video has a real sponsor, so let's just spend a few moments to talk about PCBWay. PCBWay is your one-stop solution for anything around PCB prototyping and manufacturing. But they do offer so much more services like 3D printing, CNC machining, sheet metal fabrication and even injection molding. They have a wide range of services to aid you in every stage of bringing your next project to life. Ordering through their website has been made very easy, and there is also an online chat available if you need help at every step of the ordering process. I use PCBWay for a while now and must say I'm very pleased how proactive they are with suggestions for the best outcome to the parts that I have ordered. So big thanks to PCBWay for sponsoring the video, and check them out in the link in the description down below. Now back to the resin casting. The first thing I do is set up my workspace. Resin can be messy and it's not something you want on your skin, so gloves on, safety glasses on and good ventilation. I also like to lay down paper towels, so if I do spill, cleanup is easier. ClearCast 202 mixes at a ratio of 100 parts A to 90 parts B by weight. This is why a digital scale is non-negotiable. Eyeballing is a fast way to get resin that never cures. So I'll measure part A into a cup and then part B, making sure the numbers on the scale are spot on. Here you see me going for around 15 grams of resin. This doesn't seem to be enough for all buttons, but you'll see why I do it that way in a moment. Once both parts are in, I start mixing. Slow, steady, scraping the sides and bottom. You only have about 9 minutes of pot life with this resin, so you can't take a coffee break in the middle of mixing. It's go time. After mixing, I like to degas the resin in the vacuum chamber. Just like with the silicone, you see it bubble up and then settle back down as the trapped air is released. This step is especially nice if you're going for really clear buttons. However, I leave them in no longer than 5 minutes or so, as I always have the time of pot life in mind. Now why have I just mixed up a batch of resin when I know it's not enough to fill the buttons fully? Well, because I don't need to. We are going to make galaxy swirl buttons, which basically means I want a clear top with some swirl in it and a dark background to make the galaxy we've created really pop out. And for that we need to give every button just a tiny bit of resin. I only need the first half of the mold box for this. There I fill the epoxy to like half the height. This makes the clear dome on top of each button. But when does the swirl come in? This is why I chose the ClearCast 202 in the first place. You see, the pot life makes it that I have roughly 9 minutes at normal room temperature to cast my epoxy before it starts setting. That is exactly what I want. If I put in the swirl right now before it starts setting, I risk the powder to sink to the bottom of the epoxy, which would ruin the effect. But waiting for the rest of the pot lifetime, the viscosity of the epoxy changes, it starts to harden and get way more like caramel or honey. This is the exact window I want the swirl to be placed in the epoxy, because now it stays right where I want it to be. Remember to be careful not to use too much additive powder, and way more important, to not introduce new bubbles to the surface. I used some orange mica powder here, as I think this will contrast great to the jungle green controller. Now with the swirls added, I wait for another 20 minutes or so to add the second batch of resin. Now it is more like 30 or 40 gram in total. Now is also the time to put in some color. Here I have some liquid black dye, which I put like a few dozen drops in the epoxy. Be careful not to overdo it, because we are changing the mixture of the resin here. And to not have it just be like completely black, I add some pearlescent pigments by Jacquard. These powders catch the light beautifully, and when you swirl them into the resin, you can get some amazing galaxy-like patterns. Once again, I put the epoxy in the vacuum chamber to degas, and then I have time to carefully put on the second half of the mold and make sure there are no gaps around it. After the vacuum chamber, the epoxy is ready to put into the mold box. Panic mode. Panic mode. Game over. Okay, so the basic problem we just encountered is that the epoxy has started setting way too early. I just put in just a little bit too much of a batch, and it's really hot right now. So it's really warm to the touch, and I just can't get it out of the syringe anymore. This is not workable anymore, so I have to wait and start anew with a new batch. So I need to wait now that it's hardened out fully, and then we can start anew. Too bad, but yeah, don't mix up so much resin and leave it in the vacuum chamber too long. Okay, glad you see me struggle for a bit there. This is the part I could have easily cut out of the video, but I wanted to show you that sometimes, even when you perfectly plan everything, some things will go wrong. As I said just before, this happened because there was too much resin mixed in the cup, plus I took a little too long to degas it. So, lesson learned I guess, but what do I do different this time around? Well, I mixed up around the same amount of resin, but since the buttons will go in the pressure pot anyway, I skipped the degassing stage completely. This gave me more time pouring the resin in and make sure that there was no hole missed. Yeah, and I know it's not best practice, but we will see how it turns out in a moment. Also, let me tell you that this is something you will likely not encounter with a slower cure resin. So don't be discouraged and think this is the same with all epoxy resins. Now with the mold finally filled up, I can place it inside my DIY pressure pot. This is basically a modified Gerberit HDPE tube hooked up to an air compressor. I chose this brand and material because they withstand way more pressure than I need for casting. If you want to build something like this for yourself, please be careful and do your research. Now the idea here is to pressurize the chamber to around 40 psi. Any tiny air bubbles in the resin get compressed so small that you won't see them once the resin cures. That is also why the reservoir needs to be there, as the epoxy resin will get sucked in a little and I need to make sure that enough resin is there in the first place. I also have wrapped a heat map around the pot, which helps speed up curing and make sure everything sets evenly. Once it's pressurized, I leave it alone. ClearCast 202 cures in about 90 minutes, but I usually give it extra time just to be safe. And after the cure time is up, I slowly release the pressure, crack open the lid and pull out the mold. I still let it cool off for a few hours now, so the resin can stabilize. Because if you pull the buttons too early, they sometimes can feel a little rubbery, so it's best to let them sit for a while. And there they are, brand new resin buttons. They still have a bit of flash and sprue from where the resin seeped between the mold halves, but overall they're solid, colorful and most important, bubble-free. Holding them up to the light, you can really see the pearlescent swirls and the depth of the galaxy effect. It really is one of those moments that makes all the prep work worth it. Now that we've got our resin buttons out of the mold, the last step is cleanup and finishing. I use a pair of small flush cutters to snip off any excess resin from the pour spouts. The resin already comes out looking pretty glossy, but some creators also like to polish up the buttons. But as I am pretty satisfied with the outcome, there is no need for me to work on them any further. Once the buttons are cleaned up, it's time for the final part, putting them into the controller. I've got this transparent green N64 shell and it's basically the perfect showcase for those custom buttons. Swapping them in is just a matter of dropping each one into place. A, B, start, all 4 C buttons, the L and R triggers, and of course, not to forget, the C trigger. When it's all assembled, the controller looks something straight out of a special edition release. Does anybody of you remember the DK64 one? And that's it. We went from plain old stock buttons to custom resin-cast Galaxy Swirl buttons, and along the way we covered mold making, resin mixing, vacuum degassing and pressure casting. If you're new to resin casting, this is a great project to start with because the pieces are small and forgiving, but the results are super rewarding. Worst case, you end up with a weird blob that doesn't fit anywhere and you have to start over. Either way, I think you learned something. So if you enjoyed this project, maybe try it on other consoles too. Game Boy buttons, Super Nintendo buttons, whatever you've got laying around. The process is still the same and the customization options are nearly endless. And if you want to see where I also put in custom Galaxy buttons, this video right here is what you want to see next.